Yes, today I will talk about this memory pool. I actually applied this game engine to the memory pool. I decided to implement it in a slightly more optimized form than what I'm describing today. But before explaining that, I want to focus on explaining the basics of what this memory pool is. First of all, there is this Guitar site where I first studied this memory pool, so I'm showing it to you for now, and I'll leave this at the link. Let's talk about memory pools with the content of the site. Basically, why do we need a memory pool? Now, based on this Sciple pool, in which heap memory space, do you have a memory allocation or something? There will be times when you do allocate or order free. So at this time, we allocate or release the memory in the actual heap through some key called this new rangelet. But these new laden and delete functions are what we often call this system call. What is this system call? Some function calls that I ask this kernel group for some desired function are usually called system calls. But the downside to this is that it's expensive. It has a cost. What I mean is that we're executing something in an application, and we want to allocate memory. I want to make this system call. So, what happened at this time is that the context switching occurs from user mode, which is the mode in which this application is executed, to kernel mode, where I can execute the functions of the kernel, and then back to user mode. Because of this, now these system calls are expanding and we usually talk. So, to reduce these things, we use a memory ripple, not a new delete. So for example, the way this memory pool works is to take any one large memory allocation, and whatever we do here, we do it in a way that we usually call memory ripple. The concept of getting a big allocation at once and then using it. So if we were to say, what are the advantages of this compared to the traditional new delete, for example, we want to assign some tree objects. So when we just use udelite, we're going to use something 10 times. So you have these 10 system calls. But if we say we're using a memory pool, all we need is this one memory new. It's just that, as we've shown here, in the case of 10 stocks, there are so many scattered cases, and if we call this rule 10 times when the scattered stocks are allocated in this heap, what is this memory pool? We get this linear memory allocated at once, and then we divide it into 10 object spaces in our own way and use it. From this point of view, the advantage of memory pools is that we reduce the number of system calls. In the second case, as you can see in this picture, when we're accessing the memory of 10 objects, we're continually accessing scattered places. Go like this, go like this, go like this. Then, of course, the cache hit rate is bound to drop. But compared to that, in the case of memory ripple, the probability that these objects that we want to access are located in linear memory space is higher. There is an advantage that this can also increase the cache savings rate. In other words, this memory pool has a purpose for some system call line, and secondly, there is some purpose to increase this cache hit rate, and for these two purposes, we usually use memory ripple.